Hello, so I want to have a look at threading in Python. So your program in Python can generally be referred to as just a single line with all the different commands you're doing. So each different command and the execution is going along and it has a start and then it will get to an end. There we go. That's your program. It started something, it did something, and it ended. Now, as is a single thread, a single line, a single chain of execution, if you've got a computer with, say, a CPU, that thread will run on that CPU. If you've got a quad core, so you've got 4 cores in your CPU, or maybe you've even got 2 CPUs which are both quad core, you could have all sorts of things. So each of those is a core. This program will just be running on one core. And it can only really run that way, because you've said your program is very sequential in that it's one thing after another, like a recipe for making a cake, or one example I quite like is writing a story for your English homework. What you can do instead is start using threads. So you can start utilizing these and you can start having things happening at the same time in your program. So your program will go along and at some point it can launch another thread, and that thread can then be continuing. And that separate thread can be run on a different processor. Now that thread may be something which runs all the way to the end, it may be something that stops, it may be something that needs to be managed a bit, but you can launch multiple threads. And each of those threads can be run at the same time. Because this, just having a non-threaded program, you've got to do one command, wait for it to finish, and then do the next command. With threads, you're saying that all of these commands can be run independent of each other. Now, there may be some variables being exchanged, there may be some data going here, there, and everywhere. However, the timing of it, you're saying, isn't really important. This is useful if you're doing things like networking, or things which are interfacing with other devices, because you don't want your entire program to be stopping and just hanging just because something over here is taking a long time. If, for example, here you've got it either accessing an external device or the network, or just doing something which makes the program unresponsive, you don't want that blocking up your main program. If you think about using an interface and say tkinter, sometimes you see programs which people have made and they've got one button which says I don't know, sorts all the data. When they've been testing it with about 10 values. They press the button, it's sorted, awesome, everything was nice and responsive. It goes into the real world. Suddenly, instead of 10 bits of data, there's 1,000. You press on it, and then the entire interface becomes really unresponsive, and it doesn't even let you move the window, doesn't let you do anything until it's done all of that data. That's when something like that is done in your thread, which also controls the interface, and that causes usability issues at best. In those cases, it would be much better if instead of running that code, they just launched off a thread, went back to their code, said, yep, that's all good, that's in progress, maybe grayed out the button and changed it to say processing, and then when it's finished, then get the data back and do whatever was required. Okay, so the actual code. Now, in order to use threads, there's, unsurprisingly, a module for that, import threading. And you can have when you do threading in the simplest way, you can make it all sorts of complicated, but simplest, let's say we've got a function called stuff, and all we're going to do is create a total for I in range 0 to 1000, total plus equals I. So that's adding all the numbers up to 1000, and I want a program that will actually take a little bit longer. Let's make it 1,000,000. So I've got to put another loop in there, purely to make this take longer. This is just wasting time. Yes, I could do all sorts of other things. Now let's try running the program with just stuff, seeing what that does. So thread example, run. So we're just seeing how long it will take. Think that may be slight overkill. So just trying to time it whilst we do this. I think I've done severe overkill there. There we go. So that takes less than a second. If we do that, that should take, there we go, 1.6 seconds. It allows us time to see is it running or not. So now if we want to print hello, it's not going to do that until that function has finished. So what we can do is start a thread, and we can say, okay, the target of my thread will be the command stuff. And then we just say start. Now, if we have a look at this program, it will run hello pretty much immediately. Now and it's doing all of this stuff in the background. What we can do is print the result. So let's do it so it actually just prints out the result. So now it says hello, it's processing stuff in the background. Even though we started it before we pressed hello, it's still running. What we can do is we can find out, is the thread still alive? Dot is alive. And that says true, so it is still alive, it is still running. So if we now put in a command here, dot join, what that's going to do is that's going to wait for that thread to terminate. So now it's running the thread, printed hello, then the thread finished, printed total, and it waited there until the total had been printed and the thread had finished, and then it said, okay, is it alive? Well, no, because you waited until it died. And so we can see the way that the thread is working. You could have the thread running for the entirety of the program, all sorts of things. There are ways that you can do a thread as inheriting the threading object, which may be a nice way of doing it and allowing you to change things inside it. All sorts of things you can do. But that is your basics of threading, and you can do things like networks, receiving and sending and things like that on it quite nicely. If you want to pass things into it, you can either inherit, or you can use partial or lambda to get things in and then modify things like so. I would recommend 2 videos. One of them is Tom Scott, and it's on why computers can't count, and it looks at say the view count or retweets or things like that and why they're not entirely accurate. Another one is a Computerphile video about multi-threading, which about 8 minutes in, there's a nice animation about issues which can occur when you're threading. So see what you can do with that and try and get something working. Cheers.